Hi there. Are you about to automate execution for your algo trading strategies? Then you may have run into something like this. You just developed a trading strategy that looks really promising and now you want to trade it live. All you need to do is extend your backtesting script to start sending orders when there is a trade signal. Can't be that difficult, right? Well, soon you discover that some orders won't fill. An open position isn't closed because your computer restarted. Your broker rejects the order because the ticker symbol changed. Your script will send orders you don't understand and you don't have the tools to backtrack what happened. And then the whole thing crashes. You patch your script to keep up with alarms going off everywhere, and soon you spend more time tinkering with execution code than exploring new strategies. If you struggle moving your backtested trading strategies into a live production environment, you are certainly not alone. We know from our own experience how easy it is to end up with a huge pile of isolated code snippets that becomes more and more difficult to maintain as the pile grows. If you try to take this pile into a live trading environment, things can go bad fast. The Skill Cloud Trader project flips this around completely. Our system is built from the ground up. It is designed to work in a live environment, and we will show exactly how you can implement it yourself. Welcome to Skill Cloud Academy. My name is Ryan, and these are the things we will cover in this video. We will explain the idea behind the system and then show how to install it on your machine. We will run the system, and finally, we will have a closer look at the code. But what is the Skill Cloud Trader in more specific terms? The Skill Cloud Trader is designed to solve three very basic concerns in automated trading. The first one is continuity. We want a continuously running system to execute trades for us because we don't want to sit in front of the screen all day. The system must handle unforeseen events and recover from things like crashes, broker disconnects, and network failures. Some sort of background watchdog process is needed to ensure that everything is running and send an alert if there is a problem that needs attention. The second concern is extensibility. It should be easy to extend the system with new functionality without messing up already running parts. We need some way of decoupling system tasks and run them independently, but at the same time allow them to communicate with each other. Our third main concern is about control. We need a user dashboard to get an overview of what's going on in the system at all time. What trading strategies are active, how do trading signals evolve, what positions are open, what alerts are triggered, and so on. So how can we do all this? Well, that's something my friend John has figured out, so I leave it to him to explain how we translate these three concerns into a system design.
Thank you, Ryan. Let's have a look at how we can structure our application to reach our three main objectives. First, we need to create the background service and start a continuous loop that runs in the background. There are different options to turn a Python script into a background service, and we will discuss these a bit further on. The main task of the background service is to connect and control a number of client applications. A client application is where we implement the business logic for a particular task, like a trading strategy, for example. When the background service is launched, it will start all the associated clients and begin to monitor their running status. Each client is also a background process of its own, running its own scheduled tasks and responding to its own set of events. To achieve this and decouple the clients from each other, each client will execute in its own thread. If you are not used to working with multi-threaded applications, it can sound a little daunting, but it is actually quite straightforward in Python. The client threads will be managed by the background service, and it will also contain functionality for starting and stopping individual clients to do maintenance or upgrades. If a client fails and stops unexpectedly, it should be detected by the background service and a restart should be attempted. If the client cannot be restarted, a warning should be raised and sent to the system manager. Each client needs to contain a common set of methods and properties so it can be started and managed by the background service. In addition to this, the client will contain all the specific business logic it needs to do its job. By structuring our application like this, we can make the clients very versatile and capable of handling a wide range of tasks, while at the same time organized and connected in a common framework. One type of client that we can implement is a trading client that executes a trading strategy and connects to a broker or marketplace like Interactive Brokers, Binance, or some local venue. We will go through in detail how we can build a trading client for Interactive Brokers a bit further on. But trading clients are not the only type of clients we can implement. We may want to download quote data on a regular basis from a market data provider for backtesting, or we may want to distribute a regular position and trade report. We may want to capture and store daily mark-to-market prices for open positions so it can get a continuous trail of unrealized P&L. Clients can be implemented to manage a very wide range of tasks as long as they comply with a basic pattern that allows it to run under the background service. Finally, we will implement a local web dashboard using the Dash framework for Python. This dashboard will allow us to monitor all the running clients. If we need to make changes to a client, we can manually stop it from the dashboard. We keep the same modular approach as we had with the clients when we implement our web application. It should be easy to add new pages to the dashboard where we can monitor what the clients are doing in real time. Like this one, for example. Here we have implemented a dedicated dashboard page for a pair trading strategy. We can monitor how the spread evolves for each pair, and we also get information about the current positions taken by the strategy. Alright, that was a quick overview of how we can structure the Trader project to meet our requirements. Now Ryan will take you through how to set up the environment and download a minimum viable implementation of the Trader platform so you can run it on your local machine and start working on the code.
Thanks a lot, John. That was great. Let's move on to the next step and set up the environment with the tools and dependencies we need to run the installation. Move over to skillcloudacademy.com and locate the free course called Skill Cloud Trader Project Part 1. Click to enroll the course. You will need to log in or register if you're visiting for first time. In the course page, you can download the installation project files under the Resources tab. Then unzip the folder and save it to your computer. We will start the background service and run the installation in a minute. But before we do that, let's just make sure that we got the necessary Python version installed. Check that you got Python 3.11 or higher. If not, move over to python.org and install the latest version. We also need 4 additional Python packages before we can run the system, and we can install these with pip. Our browser dashboard is based on the Plotly Dash package, so let's install this. It's a good idea to use the capital U argument to ensure that we get the latest version of all packages in case we already have some older version installed. We also need the Dash Bootstrap Components package. This provides some additional components that makes it a lot easier to style the dashboard pages. The Dash HE grid is a very flexible data grid component that will make it a lot easier for us to create nice tables. Next, we will install Pandas. We will use this package to structure and manipulate data when we start coding new clients. Finally, we're going to install a neat little package called Schedule. We will use this to schedule events in our client code. Alright, so now we have what we need to run the installation on our local computer. Open a command window and navigate to the folder where you unzipped the installation earlier. Type service.py to start the system. It takes a couple of seconds to load the dependencies and the client modules. Then we see hello messages from the 2 connected clients starting to appear on the screen. Maybe you also noticed that a local web server was started on your computer. If we open up a browser and paste in the link, we can see the Skill Cloud Trader dashboard. Right now, the dashboard is very limited. On the home page, we simply get a list of all connected clients. We can start and stop them individually if we need without affecting any of the other clients or the background service. We can also reload a client if we have done some changes to the code. To the left, we have the main menu. If we add a new client, it will automatically show up in the menu and a default page will be assigned to it. We can easily customize this page using the Plotly Dash package. It is super easy to add interactive charts and data tables to visualize client data. We can also add buttons and other widgets to control the client application. We also have a settings page. Here we will gather general settings for all the clients like broker connection details, email settings, reporting settings, and all other things we might need to centralize. We will build and configure this page later. Now we have a minimal version of the Skill Cloud Trader set up and running on our local machine. Now John will continue and give you an overview of the code modules.
We can open the project folder in VS Code and have a look at the project setup. The modules map straight into the design that we talked about earlier. The service.py module provides the continuously running background service, and this is the module that we run in order to start the system. The -server.py module contains the web server that allows us to make a connection with the web browser. Finally, the client modules are located in the client folder. This is important because the way we add clients to the system is simply by saving them to the client folder. The background service will attempt to load and start all modules in the folder under the assumption that all files in this folder are client modules. Let's open the test client.py module and see what it contains. The test client is made up of 2 main parts. The first one is a scheduled task where we instruct it to do a certain job on a regular interval. With the schedule module, we can do this almost in plain English. We tell it to run a job every 5 seconds. The second part is the job itself. In this case, the job is simply to print a hello message to the console, but it could just as well be to execute an end-of-day order or something more complicated. All clients need to be wrapped inside a class definition so they can be instantiated by the background service. We could create a client class from scratch if we want, but in this case you may have noticed that we make use of a base class. The reason for this is that all clients must provide a basic interface to be accepted as clients by the background service. The interface consists of a set of class methods and is identical for all clients. So instead of rewriting the interface code each time we want to build a new client, we have put it in a base class that can be reused. Let's take a quick look at the base class before we move on. The base class is located in the same folder as the live clients, but the file name has a leading underscore. This is a naming convention that tells the background service that it should not attempt to start this module because it is a base class. The scheduler is defined in the base class constructor to make sure that a unique scheduler instance is created for each client. The start and stop methods are also defined in the base class. The run client method is super important. This is the method that the background service calls to start the client. This method is also responsible for spawning a separate thread for the client. You may recall from Lesson 2 that we want our clients to run in parallel and be decoupled from each other. By starting a new thread and assigning the client's internal main loop to this thread, we can make all the clients execute concurrently. The main loop is also defined in the base class, and it will run until the stop flag is raised. Inside the main loop, the scheduler is instructed to run any pending job each second. This means that the time resolution for scheduled tasks is 1 second, so if we want the jobs to run with a higher precision than that, we need to override the main loop. We will talk more about this later when we look at more advanced applications and real-time event-triggered clients. Finally, let's have a brief look at the web dashboard modules. We're using the Plotly Dash package to build a web dashboard exclusively in Python. The Dash server is part of the package and allows us to run a local web server that we can connect to from a browser. But before we continue, there are a few words of caution to share. This web server is not intended for production applications. If you at some point want to allow any external connections over the internet, you should replace this server with a production-grade server. Having said that, we will only use the web server behind our firewall and we will not allow any external connections. So for now, and for our current purposes, we can live with the Dash development server. In addition to the server module, we also need to define the actual layouts that will be displayed in our browser. The first page that we see when we navigate to the dashboard in our browser is generated by the Dashboard Layout module. The dashboard page contains a navigation bar, and when we click the links in the nav bar, we will load subpages into the main dashboard container. All clients will be associated with a specific subpage. Until we change this page, a default page will be loaded. This page returns a very basic tab layout. It pulls the docstring from the client and displays it at the top of the page. But when we add new clients, we can also add customized dashboard pages for these clients. This gives us a very powerful tool to visualize the strategy calculations and monitor how trading signals are generated. We will dig much deeper into this in our next video when we implement an interactive brokers client.
All right, now we got a brief overview of the SkillCloud Trader platform. In part 2, we roll up our sleeves and implement a client that connects to interactive brokers, and we will create a dashboard page to visualize market data. Thank you for watching, and please don't forget to like and subscribe. That's what makes it possible for us to make more videos like this.